Hi everybody. In this video, I would like to demonstrate the simulation of different shapes, with different sizes, and also how the tool helps to optimize your design. You see here the view of a non-registered user, where you can start immediately the simulation without any registration. The design of the core starts by choosing the most suitable core shape for your application. In this video, I will guide you through all three shapes step by step. And we will start with the easiest shape. The round shape. For the round-shaped core, only three parameters need to be set in order to define the mechanical dimensions of the core complete: the outer diameter OD, the inner diameter ID, the height, H. For these three dimensions you can type in any values you would like to check. And here the tool shows one of its supportive features. After you put in your dimensions, in background the tool checks automatically the producibility of the core, and gives you a hint in case some of the dimensions became unusual or uncommon. This hint, for example, shows you that the chosen difference between OD and ID is too big. That means that the core may become too thick for production. For example, you can use the recommended values to design a more likely producible core, but you can also ignore the warning, and execute the simulation with your favorite values like this. You see here, that the simulation has been executed, and the results are shown. But here you see also, that the hints remain in order to display that the design is unusual. In this, and of course in any other case, feel free to contact our application engineer to discuss your design. Our application engineers will be happy to support you during the design phase, and to check internally, whether your exceptional design is producible. If you use the recommended values, you see that the hints disappear. For the height of the core, the tool gives you also feedback whether you use our standard core heights. Here, the program recognized that the chosen value is not one of our standard values for core height. Here you also will be able to run the simulation by ignoring the hint. At MAGNETEC, our nanoperm ribbon is available with different standard widths, and the ribbon width defines the height of the core. Of course, we are capable to cut the ribbon to arbitrary widths, but usually it is more attractive to use material with a standard width. The reason here is that by using ribbon with a standard width, cutting the ribbon is not necessary, and therefore the finished product becomes more efficient in perspective of costs. Therefore, you use the recommended values as well, and you see that the hint disappears. And last but not least, you choose the required permeability, and the design is completed. You can execute the simulation, and review the characteristics of the fresh designed core. Now, let's check out the oval-shaped design. For the oval-shaped core, 5 parameters are needed in order to completely define the mechanical dimensions of the core: the outer diameter, 1 OD1. The inner diameter, 1 ID1. The outer diameter, 2 OD2. The inner diameter, 2 ID2. The height, H. The procedure here is the same as for the round core. Just type in the mechanical values of the core you want to simulate. In the background, the program automatically checks the chosen values regarding logical sense and producibility. Also, here it gives you instant feedback in case something unusual is detected. For example, I type in here 80 mm. Now you see the hint that the core thickness is not constant. Let me explain this feedback a little bit more in detail. Since you have two values for outer and inner diameter, it is important to make sure that the core thickness remains the same during the complete circumference. In case the core thickness is not the same, the program immediately gives you a corresponding hint, like you can see here, the core thickness is not constant. For getting proper results, it is mandatory to keep the core thickness constant by choosing corresponding OD and ID values. After you pick the needed dimensions, the remained procedure remains the same as for the round-shaped core. That means, to choose the target permeability value, and then hit the Simulate All button to get the results. Now, let's check out the rectangular shape design. Compared to the oval shape, for the rectangular shape, one additional value needs to be defined: the inner radius, Ri. That means that for all other dimensions, the procedure remains the same as for the oval-shaped design. It is important to ensure that the radius is not too big, and also not too small. The upper limit for the inner radius is half of ID1 or ID2. It depends on what is smaller. In this case, the ID2 has 16 mm and is smaller compared to ID1. Therefore, the maximum possible inner radius is determined by ID2. If we pick a too big inner radius, then the program detects logical nonsense, because the too big radius would cause an inconsistent core thickness in the area, where the curved shape goes into the straight shape. If you pick exactly half of ID2 for the inner radius, you have a oval-shaped design. If you put a value smaller than half of ID2, then you have a rectangular shaped design. The lower limit, if I put here 2 mm, for the inner radius, ensures the producibility of the core. The background for this limit is that our core material is 20 micrometer thin ribbon material, what is wound and bent to the final core shape. Choosing a too small inner radius will cause the risk that the ribbon material may break during the manufacturing process. In case you need a design with a very small inner radius, please contact our application engineers, and together you will find the most suitable solution in respect of your requirements and producibility. After choosing the suitable and producible inner radius, you can move on with the known procedure, and execute the simulation after picking the target permeability level. You see, designing and simulating nanocrystalline cores has never been as easy and efficient as with the MAGNETEC Online Simulation Tool. We hope you enjoyed the video. Your MAGNETEC team.